AB Calculus, Note Card 60, More Integrals of Trigonometric Functions. This is the 60th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. Okay, more integrals of trig, meaning trigonometric functions. And now we're getting into a little bit of the more of what I would call the obscurities of what is needed for this AP test in May. And so we have all these rules of integration, and what these are, we can see when you went over note card lesson 27, the derivatives of the inverse trig functions, and what I recommend shortly before sitting down for the AP test is having some kind of a memorization of these things here, and particularly these two on the left, the derivative of the arcsin and the arctan. And sometimes you'll see this written as, instead of arcsin, you'll see it written as inverse sine of u, and also inverse tangent of u. Okay, so let's get back to our integration. And we're going to come back and forth to these. I don't expect many or any of you to freshly be able to memorize these things. So let's go on here. We have the integral of tangent of 2t dt. And what we're going to do is take this 2t and make a u substitution. So we're going to say let u equal 2t. And therefore du is equal to 2 dt. And dt is going to be equal to du over 2. And so that's what we're going to do, to replace this dt here. So we have the integral of tangent of u, and replacing dt with du over 2. And now, working to the right, we have 1/2, bringing this 2 in the denominator out front, tan u du. And now going back to the integral of tan u du is the negative natural log of cosine, absolute value of cosine u plus c. So negative, and we have this 1/2 ln absolute value of cosine u plus c. So just working below here, we're going to take this u and bring this back here to reinsert, so we get negative 1/2 natural logarithm of absolute value of cosine. We have 2t plus c, and that's going to be our answer. Okay, problem 2. The integral of the secant of the square root of x over 5 square root of x. This is one I had to do a little preliminary looking at here. And what we're going to do is make a u substitution on this square root of x. So we're going to say let u equal square root of x. And then we're going to go from radical form. The square root of x is going to be x to the 1/2 power. And so now we have, I'll just continue to work to the right. We have du is equal to 1/2 x to the negative 1/2 power dx. And that's going to be du is equal to 1 over 2 square root of x dx. And what is dx going to be equal to? Well, it's like you cross multiply this 2 square root of x. So dx is equal to 2 square root of x du. And so now we have something we can do here. Okay, so now just bringing this down, we have the integral of secant u, and then we have in the denominator 5 square root of x, and then we're replacing dx with 2 square root of x du. Okay, we should be able to see that we have a cancellation of square root of x divided by square root of x. And continuing below, we're going to bring out this now 2/5, because we have the 2 here in this numerator and the 5 down here in the denominator. And we have secant u du. And now what we can do is go to our integral of secant u du, and this is what we have here. We're just going to plug that in and resubstitute. So it's going to be equal to 2/5 we have the natural logarithm of the absolute value of secant u plus tangent u plus our constant integration c. And now we can take our u value of square root of x, put this in here, put this in here, and we end up with 2/5 natural logarithm of absolute value of secant square root of x plus tangent square root of x plus c. And that's going to be our answer here. So a little bit involved, but we can work through it using u substitution. Okay, next we have the integral of 3 over 1 plus x squared dx. And if we try to use a regular u substitution with this denominator, we should see that we're going to get a derivative of the denominator of 2x, and we're not going to be able to offset any x up here in the numerator. So a regular u substitution of this denominator is not going to work. Fortunately, with our trigonometric substitution, we can go, I'm going to go back here. You see this format here, number 5? the integral of 1 over 1 of the plus x squared dx. That's what we're going to use here. So first thing I'm going to do is take this 3 in the numerator outside, and we're going to be left with 1 over 1 plus x squared dx. And this takes the format of the arctangent. So we're going to have 3 arctangent. And sometimes you'll see this arctangent written as rather the inverse tangent, tan the -1 power, the inverse notation. So that's going to be x plus c. And really, that's going to be it. Okay, next, problem 4. We have a similar type of format, but instead we're going to use this number 6 here to the right, because instead of having just in the denominator 1 plus x squared, we have a squared plus x squared. So let's go ahead and look at this. We're going to get 1 over a times the arctangent of x over a plus c. So let's work this out. Okay. I'm just going to write this out as integral of 1 over x squared plus a squared dx equals 1 over a arctangent of x over a plus c. So now let's work to the right. So we would say that a is equal to 5, because 5 squared is 25. So what we have here is, I'm going to bring this 7 out front. We have 1 over x squared plus 5 squared dx. And continue to work to the right. We have 7 times 1 over a. So that's going to be 1 over a arctangent of x. And here we have x and over a, which is 5, plus our constant of integration c. So this is going to be our answer to number 4. Next, we have the integral of 1 over the square root of quantity 16 minus x squared dx. And that is going to be this format right here. Okay. So we're going to bring this down here. Say integral of 1 over square root of, we'll say, a squared minus x squared dx, and that's going to be equal to arcsin of x over a plus c. And so a is going to be equal to 4, because 4 squared is 16. And so now, working to the right, we get arcsin of x over a. That's going to be x over 4 plus c. And that's going to be our answer again. Sometimes you'll see this as the inverse function notation, sine -1, as opposed to arcsin. And that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.